this assessment, we're asked to draw a reaction coordinate diagram that rationalizes the fact that pathway B is the net favored process. Well, if we look, we really only need to look at the first two steps and draw a reaction coordinate diagram for those. And let's look at what happens first. In both cases, we're simply going to protonate an alcohol. One is secondary, one is tertiary, but for the most part, those are going to give products at the same energy. And so we can start by showing that protonation step as being kind of enthalpically neutral, because H3O plus to a protonated alcohol, about the same pKa values. And so we can do the same thing for A and B, neither of them favorable over the other. Now at this point, we've protonated our alcohol. We've got a water molecule that's going to leave. In one case, it's going to leave from a secondary carbon to make a secondary carbocation. That's the case for A. Let's go ahead and draw what that's going to look like. That's going to be an uphill process as we form the carbocation. So we might show it finishing there. We'll label this as the secondary carbocation. In pathway B, though, when that water molecule leaves, we're going to make a tertiary carbocation. And we know that tertiary carbocations are more stable because of hyperconjugation. So on our reaction coordinate diagram, we're going to expect it to finish at a lower energy. Still an uphill process, but it might finish here for our tertiary carbocation. It's for this reason we could continue drawing the reaction coordinate diagram for the other steps, but here's where that decision is made in terms of the tertiary, going through the tertiary cation instead of the secondary carbocation. Because the tertiary carbocation is more favorable, the pathway B will be favored.